All right, 9-2 reflections. Okay, so triangle ABC is congruent to triangle RST. Name the side that corresponds to BC. Well, that would be ST. All right, in the diagram, R is the perpendicular bisector of line segment AB. So a reflection is a transformation which flips a figure over a line of reflection, resulting in a mirror image of the original figure. The orientation of the figure reverses. So example, figure ABCD was reflected about or over the line Y of the Y-axis to form the figure LMNO. Figure LMNO is a reflection of the figure ABCD. So number 3, is this a reflection or not? This is not a reflection, but this is. So let's reflect triangle ABC over this line. So it has to be the same distance. So here would be B prime, and here would be C prime, and then here would be A. So we have B prime, we have C prime, and we have A prime. All right, so key concept. A reflection across line M is called a line of reflection. It's a transformation of these two properties. So if a point A is on line M, then the image of A is itself, so A prime equals A. If a point B is not on line line M, then M is the perpendicular bisector of the line B prime. You write the reflection across M that takes P and P prime as R sub M, P equals P prime. So reflections preserve distances and angle measures. So if R into point M of A equals A prime and R to point M of B equals B prime, then AB equals A prime, B prime. The angles would also be equal. So the measure of angle ABC equals the measure of angle A prime, B prime, C prime. If AC is 3 units, A prime, C prime is 3 units. If the measure of angle ABC is 55 degrees, then the measure of A prime, B prime, C prime is also 55 degrees. So let's try reflecting. So point P has coordinates 3, 4. So R x equals 1 of P equals P prime. So what are the coordinates of the image of P prime? Okay, so the first thing is we're going to graph the point P and then the line of reflection x equals 1. So the point P is at 3, 4. Here is the point P, and here is the point x equals 1, or the line x equals 1. Okay. So number 10, describe the point P in relation to the line of reflection. Point P is 2 units to the right of the line of reflection. So describe the image P prime in the relation to the line of reflection. So point P and image P prime are the same distance from the line of reflection, but in opposite directions. So P prime is 2 units to the left of the line of XY. So now we're going to graph P prime and write its coordinates. So same thing, P is at 0.34, and then we have the line x equals 1. So then 2 units would be here, 2 units would be here, P prime. So the coordinates would be at -1, 4. Problem number 2. All right, so we're going to graph triangle ABC where A is at -3, 4, B is at 0, 1, and C is at 4, 2. We're going to graph the reflection into the y-axis of the triangle A prime, B prime, C prime. So first thing, we have triangle ABC. Here's the x-axis, which is dotted for us already. Okay, so draw a line perpendicular to the line of reflection that crosses through the point A. So right there, it's done. All right, locate A prime, so it's perpendicular bisector. So here's A prime, and it's the same number of units, done. Repeat the same steps. So B right there is 1 unit, so we want 1 unit away, there's B prime. C is 1, 2 units away this way, so it's going to be 1, 2 units away this way. So there's C prime. Here we go, we will connect the dots, and there is my reflection. All right, problem number 4. So in the diagram, R of T is GTRTH equals J and RTD equals D. Okay. Can use the properties to prove that this is an equilateral triangle. All right, so what do we know here? We know this is a perpendicular line. This is equal to this. Okay. We know that RT, so G equals itself. That's from the first statement right here. We know H and J are equal. That's from this statement here. And we know that D is itself equal to it. Okay, cool deal. Okay. All right. So a triangle is equilateral if all three sides are the same length. So GH must equal GY because it's a reflection, or GJ, excuse me, and HG must equal JD. So GH must equal JD. GH must equal GJ, and we know HD must equal JD. So we know that much. Okay. So we need to prove that the lengths to the following properties. Okay. Can I determine this using reflections? No. Okay, so can the properties of reflections be used to prove it's an equilateral triangle? It cannot. I don't have enough information. I might be able to prove it's isosceles. I have two congruent triangles. That's about it. Okay. So a classmate sketched R sub T of A, which is A prime as shown in this example. Explain your classmate's error. Well, I can see the big one right off the bat. It's not a perpendicular line, but let's go ahead and do this. So A. Okay. So line R is the perpendicular bisector of A prime. So in the classmate's drawing, line R is not perpendicular to A prime. All right, so here's A. The perpendicular line should have been here. So its line should have been here. Here is A prime. And that's the end of this section.